Hello everyone, welcome to Mentor's Buddy. My name is Akhil Gautam. Now today we are going to discuss another type of question which is based on the logic of PNC only. Coming to the question says a manufacturer of a chocolate makes 6 different flavors of chocolates. The chocolates are sold in the boxes of 10. So how many different boxes of chocolates can be made? Now in order to solve this question, we have to understand the concept, the logic of distribution. So coming and understanding the concept of distribution. Okay, let's say there are 3 people, A, B and C. There are 3 people, A, B and C, and there were 5 seats are available. Let's say this is 1, 2, 3, 4 and 5. 5 seats are available. And the question is, in how many ways can these 3 people, A, B and C, can be seated on these 5 seats? So the first option or the first way in order to solve this question is I'll select 3 seats out of these 5 seats. So selection of 3 seats will be 5, C3, and the arrangement of the 3 people on those 3 chairs will be 3 factorial. So that can be written as like 5C3 into 5 factorial. The second way to solve the similar question can be written as directly 5P3. 5P3 implies the selection of the 3 seats out of the 5 seats, and at the same time they are arranging them as well. So this is selection and then arrangement, this is selection plus arrangement. But the best way, the unique approach to solve this question without applying any formula and applying only logic, that is, let's say the very first man is coming, that is A, and the question is in how many ways A can be seated on one of these bench. So A must be having how many options? That will be 5 options. So that will be 5 ways. A can be seated on 5 ways. So now let's say A occupies this position. At this position A is seated. Now coming to B. B is having now how many options? That will be 1, 2, 3 and 4. So B can be seated in how many ways? That will be into 4 ways. So let's say B grab another seat out of these remaining 4 seats. That'll be how many ways? 4 ways. Now coming to C. Now how many options are left for C? That'll be 1, 2 and C. So C can be choosing one of these seat in how many ways? That'll be remaining 3 ways. So that'll be equals to, let's say C opt this position. So that is going to be equal to how much? 5 into 4 into 3. That'll be equals to how much? 60 ways. So in 60 ways A, B and C can be seated on these 5 positions. Now applying the similar logic in another type of question. Now the question is, in how many ways 7 distinct chocolate can be divided among 3 kids. So these are 7 distinct chocolates can be divided among 3 kids. So one of the best approach to solve these kind of question is, so let's say this is first kid, this is second kid and this is third kid. So the logic in this case is going to vary. How come this is going to vary from the previous question? So coming to the very first chocolate. So very first chocolate is having how many options? There will be first option, second option and third option. So first chocolate can go to either of the 3 kids. There will be 3 options. And now coming to the second chocolate is having how many options now? Again 1, 2 and 3. That will be again 3 ways. Similarly third chocolate will be having how many options? 1, 2 and 3. Again that will be 3 ways. Fourth chocolate 3 ways. Fifth chocolate 3 ways. Sixth chocolate 3 ways. And seventh chocolate will be again 3 ways. So in this case answer should be 3 to the power 7. Understanding that answer should be 3 to the power 7. Now what is the difference between these two questions? In this first question, if one of the seat is occupied by A, obviously B can't occupy that seat again. So there was going to be one option reduced, that will be 4 ways. For the last person 2 options are reduced, that is the reason 3 ways. But in this question, if the first chocolate has gone to either one of the kid, like kid 1, 2 or 3, so the second chocolate can also have another 3 options, because the the second chocolate can go to the person who have already got one chocolate. So no such case is going to be formed in the second case, the one which is formed in the first case. One another approach, or let's say deal the same question, same type of logic in one other question, that is, in how many ways 4 distinct letters can go in 3 letter boxes. So let's say this is box 1, this is box 2, and this is box 3. So the question says, in how many ways 4 distinct letters can go in 3 letter boxes. So first letter will be having how many options? 3 options. It can go in either of the box. Second letter is having how many options? Again 3 options. Third letter how many options? 3 options. Fourth letter how many options? Again 3 options. So this can be written as directly like 3 to the power 4. That's the correct answer. So one another just kind of form to solve these kind of question is, for the last 2 type I'm saying, apply directly this, where to the power what. This is a sort of formula or whatever you can understand, but I certainly believe the students, the people should understand the logic and the reasoning behind the question. So applying this formula, where to the power what, where the chocolates need to be distributed, that is among kids, so that'll be 3. What is need to be distributed, that is chocolates, that'll be 7. The answer will be 3 to the power 7. Similarly, where the letters need to be distributed, that will be letter boxes. How many letter boxes were there? That'll be 3. And what need to be distributed, letters need to be distributed, they were how much? 4. That'll be directly 3 to the power 4. Now, so I believe this logic is clear in order to solve the coming question. Now coming to the question which we have seen, it says a manufacturer of a chocolate makes 6 different flavors of chocolate. Let's say I am naming the 6 different flavor of chocolates to be as like A, B, C, D, E and F. These are 6 different type of chocolates, and the chocolates are sold in a box of 10. Implies one of the box, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 places where 10 chocolates can be filled in one box. So now the question is, how many different type of boxes can be prepared with these chocolates? Now coming to the same logic, this first position, this first space can occupy how many type of chocolates? Or you can say, so that can be written as like 6 type of chocolates are possible here, implies 6 ways. Now at second position, again 6, either of the one of the chocolate is shortlisted over here, that'll be again 6 ways. So what is this 6? Basically 6 is 6C1. Out of 6 I'm going to select one chocolate, I'm going to place here. Again out of 6 chocolate I'm going to shortlist one chocolate, I'm going to place here, I'm going to place here. So this is again going to be 6 ways. 6 ways, 6 ways, 6 ways, 6 ways, 6 ways and 6 ways. So in this case answer will be 6 to the power 10. So 6 to the power 10 different type of options or different type of boxes can be prepared by these chocolates. I'm again repeating it. What exactly the question was asking, that how many different type of boxes can be prepared. So first position occupying out of 6 one of the chocolates, so 6C1, that'll be 6 ways. This will be again 6 ways, 6 ways, 6 ways and so on. That'll be 6 to the power 10. So correct answer in this case should be 6 to the power 10. That is option number D.